So our next topic is to show how the reactive streams frameworks we've talked about, RxJava, Project Reactor, and so on, map onto the reactive programming principles that we mentioned earlier. And this is actually really cool, and this, of course, is what these frameworks were designed to do. They were designed to embody the reactive programming principles, and let's talk about how that works. So from a responsiveness point of view, remember, responsiveness is all about trying to avoid blocking the code that makes calls, and there's various ways this happens. First, let's just reiterate why we want to avoid blocking. And the reason we want to avoid blocking is because blocking underutilizes processor cores, impedes inherent parallelism, and complicates program structure. And the way that's done with RxJava and Project Reactor is by using various operators like subscribe on, publish on, observe on, and so on, which can be used to designate where the operators perform the processing, what thread or threads they will perform the processing in. And so you can get very fine-grained control over specifically where operators are going to run, which is pretty cool. Something else you can do is you can also explicitly avoid changing threads. That's another potential source that makes your program less responsive. Why is that? That's because changing threads can incur excessive synchronization overhead, context switching, memory management overhead, cache management overhead, and so on. And so once again, you get fine-grained control over this using subscribe on, publish on, observe on, and so on to get very, very fine-grained control over how things work. From the resiliency point of view, this should look very similar to what we talked about with Java completable futures. There are exception handling methods that are defined in reactive streams frameworks that make the program more resilient to failures. And these exceptions will decouple error processing from normal operations. So that works very much the same way things do in completable futures. We'll see the method names are different. Their semantics are different. There's some subtleties that we'll have to go over, but they have a way to separate out normal processing from error processing. Always keep in mind that reactive streams are localized to a single process, not a cluster of processes. So the failures that are occurring here are failures that are occurring within a process, not a machine going down in a cluster per se. Next topic is elasticity. How you get elasticity, how you get to scale things up as workload grows is by allowing asynchronous computations to run in a pool of threads atop a set of cores, which then allows the system to grow and scale more effectively. And there's a bunch of different ways to do this. RxJava has these things called schedulers, and there's a whole gaggle of them. There's an IO scheduler and a computation scheduler and so on. And then Project Reactor also has a bunch of schedulers as well. Oddly enough, the schedulers that are defined in RxJava are not named quite exactly the same thing that they're named in Project Reactor and vice versa. I'm not entirely sure why, but they're not the same, but they play the same role. They allow the program fine-grained control over where computations will run, what thread or what pool of threads the computations will run in. And we'll talk a lot about that. It's very important to understand how schedulers work and why they're designed the way they are. And then there's also this concept of message-driven, which we talked about before. Basically, everything that's implemented in these frameworks ultimately is done by messages, things like the common fork join pool, the way in which the various pieces are put together to make a pipeline of fluxes are done through passing messages between different parts of the system. And you get an API-driven, method-oriented view, but under the hood, there's a lot of messaging taking place to make things work with respect to where the computations take place, whether they run in one thread versus another, and so on. So that's just a quick mapping of reactive streams onto the reactive programming principles. You might ask at this point, well, how does that really differ from completable futures? The answer is, at a high level, they're very similar, but when we get into the details of how you program them, you'll see that reactive streams are designed more intentionally to be reactive from the ground up, whereas the streams and completable futures stuff we talked about required a little bit more work on your part to assemble the pieces together.